Good morning, students. So we discussed in the last class the topic is so what is the Boyle's law and Charles law, and what is the equation of the ideal gas, okay, and what is the ideal gas, and ideal gas equation PV is equal to nRT. PV is equal to nRT, that is the ideal gas equation. And so which is the best method, okay, which is the best method by using of the preparing of the thermometers, okay, thermometer. Okay, so that law is the Charles law is a better purpose. So already we discussed in a last class. Okay, got it. Now today discuss the another topic is thermal conductivity. Okay, so thermal conductivity. So what is the thermal conduction? Okay, so what is the conduction? Already we discussed in last class conduction, convection, radiation. Okay, so conduction means so the energy is transfer one place to another place. Okay, or hot body to cool body. Okay, so hot object to cool weather is taken. Any examples also taken. So the heat is transferred. The heat is transferred without moving of the particles, or okay, without moving of the particles, and only due to the collisions of the particles, the heat is transferred from one place to another place, or hot body, cool body. Okay, so that type of the transmission or the heat transfer, that is called as a conduction. Got it? What is the conduction? So conduction means the heat is transferred from one place to another place, only molecular collisions, okay, without a transfer for matter. So that is the type of that made of is called as a conduction, is called as a conduction. Okay, got it. So now here discuss the topic is thermal conductivity. Thermal conductivity. So what mean of the conductivity? Okay, so thermal conductivity. So what mean of the thermal conductivity? So conductivity means so the ability of the heat is flow. The ability of the heat is conducted. Heat is transferred. Okay, so do in a solid bodies is called as a thermal conductivity. Thermal conductivity. What mean of the thermal conductivity? So thermal conductivity means the heat is transferred. Okay, so thermal conductivity, that is what is the mean of the conduction? So heat conduction means heat is transferred. So ability means samarthyam. Okay, ability means samarthyam. So ability of the flow of the conduction of the heat in a solid bodies is called as a thermal conductivity. Thermal conductivity. Got it? So now discuss the coefficient of thermal conductivity. Derive the equation of the coefficient of thermal conductivity. Okay, so the ability of the heat flow is called as a conductivity. Now to derive the equation or to find out the equation, so that is coefficient of thermal conductivity. Coefficient of thermal conductivity. Now here taken slab. This is the slab taken. So the area of cross section is taken A. Got it? These two faces are maintained, that is E and F. So this is called as a high temperature, that is the Q2 degrees C, and this is called as a Q1 degrees C. Okay, so the difference between these two pieces is taken D. Okay, so now we consider the one of the taken is a slab. So the area of cross section of this slab is taken A. Area of cross section of this slab is taken A. And it is maintained the temperature, that is the Q2 degrees C and Q1 degrees C. This is called as the higher temperature, this is the lower temperature. Now is taken in general, so that is called as a higher, that is a hot body. So this is called as a weather or cool body or cool object is taken, that is the maintaining the temperature Q1 degrees C. and these two phases are E and phases are opposite phases, and maintaining the temperatures Q2 degrees C and Q1 degrees C. And so the difference between these two phases, is taken D. The difference between the two phases is taken D. Got it? Area of cross section is A, and maintaining the temperature E and F, two phases. So that is the Q2 degrees C and Q1 degrees C. Difference between these two phases taken D. Okay, got it? Now, so the heat conducted, the conducting of the heat flow between the two phases, the conduction of the heat. The conduction of the heat, that is the Q. Conduction of the heat, that is the Q. Q is directly proportional to area of cross section of slab. Area of cross section of slab. That means the Q means conductor of heat. Usna vahakatvam, conductor of heat. So the Q is directly proportional to the area of cross section. That's okay. And now is taken, that is a first point or first equation. Now, so the conduction of the heat, okay, so the conduction of the heat is directly proportional to the temperature difference between, so that is the Q2 degrees C and Q1 degrees C. Okay, got it? So the Q is directly proportional to Q2 degrees C minus Q1 degrees C. Now, so the Q is directly proportional to the time of flow. Okay, so time of flow between the two phases is taken, and so the Q, that is the conduction of the heat, is inversely proportional. Okay, so inversely proportional to the difference between the two phases. So taken 1 by D or 1 by R or 1 by X is taken any one. Okay, got it? So the conduction of the heat is flow is directly proportional to the area of cross section. Okay, got it? And so now another term is taken. So the Q is directly proportional to the Q2 degrees C minus Q1 degrees C. The temperature difference between the two phases. So equation 2. And so the Q, conduction of the heat, is directly proportional to the rate of flow. That is the third equation. And Q is directly proportional to 1 by D. So 1 by D is nothing but universally proportional to the, okay, the difference between the two phases. So the Q is inversely proportional to 1 by D. So these four equations are practicals also proved. Okay, practicals is also possible. So the four equations are clubbed. We can write the form, that is the Q is directly proportional to the A T2 minus T1, okay, into T by taken D. So D is inversely proportional. Okay, so the proportional can be neglected, taken some constant, that is called as the K. Okay, K into A into theta 2 minus theta 1 degree and T by D. Okay, got it? So K is called as a coefficient of thermal conductivity. K means coefficient of thermal conductivity. So we can write the equation K. So K is equal to Q into D by A into theta 2 minus theta 1 into T. So K is called as a coefficient of thermal conductivity. So that means, what means of the coefficient of thermal conductivity? So that means, so coefficient, that is the conduction of the heat conducted. Okay, so the heat conducted, so for second, for unit cross section area, for second or for unit time and unit cross section area, and so the unit gradient, that is the radiation gradient, that is a D by theta 2 minus theta 1 is called as a radiant gradient. Okay, radiant gradient is taken 1 unit. Okay, so E is called as a, K is called as a Q. So the heat conductivity is called as the coefficient of thermal conductivity. What mean of the coefficient of thermal conductivity? So D is equal to taken 1 and A is equal to taken 1 and theta 2 minus theta 1 is equal to taken 1. 1 means 1 degree C. T is equal to 1 second. So these two all are 1 is taken or 1 unit is taken. So that particular situation is taken Q. The conductance of the heat is known as a coefficient of thermal conductivity. Coefficient of thermal conductivity. Got it? Okay. So what is the thermal conductivity? So ability of the flow of the heat is called as the thermal conductivity. Now we have taken hot body and cool body. So the heat flow. Okay, so the conduction of the heat is the difference of the parameters A, theta 2 minus theta 1, T and universal proportional to the difference. So we can write the four equations are clubbed and we can write the equation. So Q is the direct proportional to A, theta 2 minus theta 1 into T by D. K is called as H. So K is called as the coefficient of thermal conductivity. Got it? Okay, right.